Okay, I'm starting another recording here. I heard back from, or I got another question in my research by somebody who I didn't know, I didn't recognize, but then I noticed he had co-published with the math professor Lou Kaufman on the Riemann hypothesis, so I knew he was some kind of high-level logician or logician. I don't know how you say that word, logician. Um, so then I decided to. He asked me to explain my research, so I just explained it to him, and I didn't really expect him to understand me. And then he gave me this response, which he gave me a long response, but I'll just read this one sentence. I'm going to hold onto the undertone overtone relations of F and G to C as indicative of noncommutativity. So then I discovered, I'm like, all right, he actually understood me, so this is very unusual. So I'm like, all right, who is this guy? And I realized that he was considered the protege of George Spencer Brown, who was a very famous mathematician and logician, and I know that Lou Kaufman relies on George Spencer Brown, so that piqued my interest even more. So then I finally asked him, well, did he go into academia if he was the protege of George Spencer Brown? And it turns out he was actually close friends with George Spencer Brown and also his collaborator on the Riemann hypothesis, and he has new research published on that. And he said he did not load the research himself, so somebody else loaded it for him. So he has a private life. I did track down this article. He said he did not upload this article. Somebody else loaded it for him, but so I won't go into that. But anyway, Luke Hoffman says that when he met James Flagg, he realized that they were working on the same concept, and Kaufman coined this phrase, the Flagg resolution. It has to do with simultaneity that is noncommutative and also nonlocal. So when I realized that James Flagg had made this invention, this Flagg resolution, I realized that actually was the foundation for Luke Hoffman's claim that I had been citing back to James Flagg as my explanation. And so I'm like, little did I know that the person who asked me this question actually was the originator of the concept I was trying to explain to him. And then, so that was pretty hilarious. And so, then, as Luke Hoffman explains, that there's a strong non-locality of the Flagg resolution, and the world is one. And then, but there's this underlying non-locality behind the one that's non-commutative. So how do we encounter this? Well, you end up getting a paradox, which is usually called the liar's paradox, but it's a big problem in set theory, and it's not considered solved. And so the Flagg resolution is that you have this simultaneity that's essentially non-commutative, as I will show, and also non-local. So when you replace a paradox with a substitution that's non-local, meaning it's universal, then you end up getting not J equals J. And also, this is what Eddie Oceans relied on for his quantum logic. And James Flagg said that he was an acquaintance of Eddie Ocean's through Luke Hoffman also. And so the Flagg resolution gives a method that takes a seemingly contradictory entity at face value, and through logical substitution, then you end up getting, if you look at J or not J alone, you see this pattern of, so you basically have these two times that are overlapping, so you get an iteration in time. And then, so when they overlap like that, it's basically the same thing as what I was saying, that you're getting F equals 3 equals G at the same time. In other words, you could say that 3 as time equals J or not J at the same time. So that would be the same thing as this Flagg resolution. And so the Flagg resolutions is a meta statement about the structure of time, and it becomes a way of maintaining synchronicity by making either no phase shift or simultaneous phase shifts. So that's what we're talking about, is these simultaneous phase shifts. So that's why he was able to understand what I was trying to tell him, because that's, in other words, this is something I had just figured out when I was in high school. And I thought, is there anything to this? I mean, logically, this is the truth based on the empirical resonance of the music theory. And so here, this is the actual explanation I gave to him before I realized he was the originator of the concept I was trying to explain to him. So he had first, when I first explained the music theory, he immediately, assumed it was referring to an octave as a wavelength, but no, because it's relying on a listening process, so there's no external symmetry established originally as a physical wavelength, and so you're putting biology primary to physics. So I go into that whole extended explanation, and not realizing that he was an expert in mathematics and logic, propositional logic. Anyway, so then we went on to discuss some of his research, and that inspired me to learn some more about math, whatever. And so I was very excited to get this little promotional quote from him, or some corroboration of my claim. And just wanted to thank him for inspiring me to learn some more mathematics. This was the key phrase that he kind of realized, that sort of explained it for him. So if you have isospectral frequencies, because the 3 as frequency is a perfect fifth as listening in both cases as an undertone and overtone, but the geometry is not isomorphic, since it is C to F as undertone, C to G as overtone. So that sentence right there was the clincher concept for him that made sense. And again, if you look back at this, just imagine this being the undertones, and then as 2 and 3, and the overtones as 3 and 2, and you get the exact same thing, where you get this simultaneous phase shift of the undertones and overtones that's actually non-local and noncommutative. And Luke Hoffman's big point is that this exists as a precursor of space-time. It's a simultaneity that's not in time as we define it, as a linear time of causation, or that exists in space-time or time-space. So in that way, it's what Luke Hoffman calls primordial time. So there we go. Thank you.